Hi everyone. Today is going to be lesson 1.6. Okay, so now we're going to talk about balancing redox reactions. So we've talked about identifying the different species. We know what's oxidized, what's reduced, etc., etc. Now we're going to talk about how do we balance these equations, because as you saw last lesson, some of them can get really complex here. So simple redox reactions can be balanced by inspection or trial and error. So by inspection, that's how you've always balanced them. Okay, so you're looking at the atoms on both sides and trying to balance those. However, many redox reactions are just too complex for those methods alone. So we have two methods available to us. The first one's called the number change method. So this is having to do with oxidation numbers. The next one is the half reaction method. So we're going to save this, the second one, for unit 6. And the one we're going to learn today is this number change method here. Both of these methods, though, are based on the premise that the total number of electrons lost in oxidation, remember that's our Leo, lost in oxidation, are going to be equal to the total number of electrons gained in reduction. Okay, so we've got our Leo, the lion goes grr. Now, so again, we're going to look through the oxidation number change method today. So a redox equation is balanced by comparing the increases and decreases in oxidation numbers. So your very first step here is going to be to assign oxidation numbers. So just like we did in the last lesson here. So -2, +4, 0, -2, +2, -2, and then this is going to be +3 here. So I've determined my oxidation numbers here, and now I'm going to go to the next step. I'm just going to recopy these because I need these here. +4, 0, -2, +2, -2, +3. Okay, so we are going to identify what is oxidized and reduced. So we're going to do the same thing as we did the other day. So we know that iron, this is going to go from +3 to 0, so it's becoming more negative. So this is going to be Gr. And then your what was oxidized is going to be the copper. So the copper becomes more positive, so that's Leo, so losing electrons. Okay, so now I have identified what is oxidized and what is reduced. Those are the only ones that have changed. Step 3, you're going to make the total increase in oxidation number equal to the total decrease in oxidation number by using coefficients. So if we look at the Leo first, I go from +2 to +4, so that is a change of +2. If I look at the iron here, I go from +3 to 0. So that is a change of -3. So what you are going to do here is you're going to have to get that, because remember, losing electrons, this is 2 electrons lost, and this is 3 electrons gained. Now those have to be equal to each other. So what you're going to have to do is find the lowest common multiple between those and think to yourself, okay, well, if I make those both 6, have a magnitude of 6, then they're going to be equal to each other. So I'm going to multiply this one by 3, multiply this one by 2, because then I have +6 and -6, and I'm going to use coefficients to do that. So I've got a 3 here, remember, so that means I need 3 carbons, and if I have 3 carbons over there, I need 3 carbons over here. On this side now, I've got a 2, so I've already got 2 irons here, so I don't need to worry about that, but I need to put 2 irons there. At this point, the oxidation numbers have been balanced, and so your last step is to just check and make sure the equation is balanced for both atoms and charge. So you want to make sure your oxygens are all balanced there, and that's all that this equation has. Other ones may be more complex. Okay, so fairly straightforward. Now, we're going to do this equation here. Now, obviously, this one is more complex, so this one would be a little tougher to balance using just inspection, because it's got a lot of different things going on here, right? Lots of oxygens, lots of whatever. So what we're going to do, we're going to use our strategy here, where your very first step is going to be to identify the oxidation numbers and then go from there. I would like you to pause the video and just try this one on your own, and then check your work, but I'm going to work through it here. So this is going to be -2 +4, -2 +3 plus 1, negative 2 plus 1, 0, negative 2 plus 1, negative 2 plus 6 plus 1. Okay, so now looking at this, I've got all my oxidation numbers, and you will discover that chromate, the chromium, changed. We went from plus 6 to plus 3. So it became more negative. So this is my GR, and that was by negative 3. And then the other side of that, the other thing that changed is the sulfur, right? So sulfur went from 0 to plus 4. So this is your Leo, and that was by 4 that worked. Now, you have to get those two to balance each other, right? The oxidation numbers have to be balanced each other. So whatever is lost has to be gained. The electrons don't just disappear or appear, right? They always have to be accounted for. So my lowest common multiple between 3 and 4 is going to be 12. So I'm going to multiply this one by 3, which means I need 3 sulfurs here and 3 sulfurs over here. This side, now I'm going to look at the GR, the reduced side. I'm going to multiply this by 4 to make 12. And so I look over here, chromium, I've already got 2 there, so I only need a 2 in front. And then on this side, I already have a 2. Hold on. Oh, wait, sorry. Blanked out there. This thing making these videos, it's a lot less stressful in person when I make a mistake. So I need a 2 here because I need 4 chromiums altogether. So I'm going to use the coefficients 2 there. And so now this is an example where now you need to balance by inspection the rest of them because it's not going to work out. So you've got sulfur and chromium already taken care of. So let's look at a potassium now. So you've got 2 potassiums here. You only have 1 here. So if I put a 2 there, I believe, no, and then you're going to do hydrogens next. So I've got 2 hydrogens here. Where are we at? Oh, no, I was wrong, sorry. Again, made mistake, oh my goodness. I've got 4 potassiums here. I better erase that. My apologies, people. Oh, I think I was blue. So I'm going to have 4. Now it makes sense to me. Okay, so now we look at hydrogens, and I've got 4 hydrogens on the right-hand side, so I'm going to need a 2 here. And then you just want to double check and make sure your oxygens are fine. So I've got 14, 15, 16 on this side, and then here I've got 6, plus 6 is 12. Plus 4 is 16, so yes, that is balanced. So this equation would be quite difficult to balance without using this method, okay? So your assignment, you can do exercise 6. Now I have the key up on the website, so you can check that. You really want to practice this. You want to make sure that you're, you know what you're doing. Okay, thanks everyone.